Welcome to the Professional Python Workflow, your guide to mastering virtual environments, dependency isolation, and terminal setup. The title slide shows a terminal prompt with .venv. That prefix in parentheses is the visual signature of a properly isolated Python environment. By the end of this module, you'll understand exactly what the prompt means and why it matters. Every professional Python project uses a virtual environment. Every assignment requires one. This isn't a preference, it's an industry standard, and for good reason. You'll learn how to create and isolated sandboxes for each project, install packages safely inside of it, freeze your dependencies into a reproducible blueprint, protect your repository from bloat, and configure your terminal to make the whole workflow faster. This module eliminates an entire category of frustrating bugs before they can happen. This slide illustrates dependency hell, the core problem with virtual environments solve. The scenario: in month 1, Project A installs Pandas 1.5 in the global Python install. In month 6, Project C installs Pandas 2.0 in the same global space. The update overwrites the previous version and Project's API breaks. The lightning bolt and API broken label say it plainly. Without isolation, one project's update is another project's destruction. This isn't a hypothetical, it's a reality of shared global environments. The more projects you run on the same machine, the more likely this conflict becomes. Data science students hit this constantly when upgrading packages for a new assignment or breaking an old one. Virtual environments eliminate this entirely by giving each project its own private package space, where upgrades in one project are completely invisible to all others. This slide shows the solution. A virtual environment acts as a sandbox, an isolated box containing its own Python interpreter and its own private site packages folder. The diagram shows Project A with Pandas 1.5 in one box, and Project C with Pandas 2.0 in a separate box, both sitting inside the global system without touching each other. The key sentence on this slide is installing updates in one project never touches the other. This is the fundamental guarantee that virtual environments provide. Each project gets its own contained universe. You can upgrade, downgrade, install experimental packages, or break things completely inside one environment with zero risk of any other project on your machine. The .env folder, by convention named with a leading dot to mark it as hidden infrastructure, lives inside your project directory and travels with the project. This comparison table makes the case for virtual environments definitively. 4 dimensions of comparison. Scope. Global environments are shared across every project on your machine. Virtual environments are isolated entirely to one specific project folder. Risk. Global environments carry a guaranteed dependency hell rating over time. Virtual environments carry zero risk. This is safely sandboxed. Portability. Global environments are impossible to recreate accurately on another computer. Virtual environments are 100% reproducible via a simple text file, requirements.txt. Use case. Global environments are marked never for active development. Virtual environments are the professional standard from day one. There's no trade-off here. Virtual environments are strictly superior for project work. The only reason to use the global environment is for one-off system tools. For every assignment in this course and every Python project you build, you must use a virtual environment. This slide dissects the single command that creates your virtual environment, python 3-m venv.venv. Each component is labeled Python. Python 3 calls the global Python interpreter. -m is the flag telling Python to run built-in module as a script. venv is that module, Python's built-in virtual environment creator, included since Python 3.3. No installation is required. .venv is the target directory name. The Dot prefix makes it hidden by convention. Following standard industry practice, running this command creates a .venv folder in your project directory, containing an isolated Python interpreter and a private pip installation. This command runs once per project from the project root while you're not inside an environment. You create the box first, then step inside it. After this, every package you install always stays contained in this one project. This slide covers activation, the context switch that tells your terminal to use the virtual environment instead of the global. The command on Linux and Mac is source.venv/bin/activate. On Windows WSL, it's source -venv/capitalized scripts/activate. The result is immediate and visible. Your prompt changes your user at Mac ~project to .env. User at Mac project that the parentheses .venv prefix is your visual confirmation that you've safely inside of the sandbox. This is the critical habit. Always look for that prefix before installing packages or running your script. If it's not there, you're in the wrong environment. When you're done working, type deactivate to return to the global system. The activation command must be run every time you open a new terminal session. It does not persist across sessions. Build the habit, open the terminal, navigate to the project, and activate. This slide covers package management. Inside an active virtual environment, 4 pip commands to know. Pip install with a package installs a package locally to your .venv only. It never touches the global system. Pip list shows every package currently installed in this environment. Pip show of a package displays the version and dependency details for a specific package. Pip install -- upgrade of some package upgrades a package safely contained in this environment. The warning at the bottom is critical. If you run pip install without the environment active, without that .venv prefix in your prompt, packages install globally and contaminate the shared system. You'll get a module not found error when you try to run your project later because the project's environment doesn't have the package. Always confirm the .venv prefix before running any pip command. This slide introduces the requirements.txt file. This is the blueprint that makes your environment reproducible. The workflow has 3 phases. Phase 1, the snapshot. Pip freeze with an arrow marker of requirements.txt captures every package and its exact version from your active virtual environment into a text file. The result looks something like pandas is equivalent to 2.0.0. NumPy is equivalent to 1.24.3. scikit-learn is equivalent to 1.2.2. Phase 2, the blueprint. This minimal text file is what you commit to GitHub instead of your entire .venv folder. Phase 3, rebuild. Anyone who clones your repository can recreate your exact environment with pip install r requirements.txt. The bottom caption says it clearly. This is how development works. Any teammate, grader, or server can run your code in a properly matching environment from this one file. Requirements.txt is the contract between your code and the environment it needs to run. This slide covers the get-ignore rule. One of the most important hygiene habits in Python development, the danger scenario, committing the .venv folder to GitHub. The .venv directory is 50 to 200 megabytes of binary files, compiled extensions, interpreter copies, cache data. It would make your repository massive, slow to clone, and potentially platform specific. The solution is to add the .venv to your get-ignore file with the echo.venv greater than to the get ignore. Then commit only requirements.txt in your source files. The result is a clean, lightweight repository that anyone can clone and rebuild in seconds. The rule is absolute. Never commit .venv to GitHub. It is a massive and 100% reproducible from your requirements file. If you ever see a Python repository with that folder inside its assigned developer has skipped this step. This slide shows how to eliminate the two most repetitive commands in your Python workflow using the shell aliases. Add 2 lines to the rc. Alias env is equal to python 3-m venv.venv, and the alias act is source .venv/bin/activate. Now, instead of typing the full command every time, you simply type env to create a virtual environment and act to activate it. The 3-step setup. Add to .zhush run is source ~/zhushrc to apply the changes to your current session. Then run the env or act. The note at the bottom explains why this matters. The shell configuration files run every time you open your terminal. Building custom aliases create muscle memory and raw speed. Over a semester of development, these 2 aliases save you up to hundreds of keystrokes and eliminate the forgot to activate error because activation becomes a 1 keystroke habit. This slide gives you the complete 5-stage project setup sequence. The ritual to burn into muscle memory for creating every new Python project. Stage 1, create. So this is python 3-m.venv or your env alias. Stage 2, activate. Source.venv/bin/activate or your act alias. Confirm that the .venv prefix appears. Stage 3, build. Pip install package for each dependency in your project needs. Stage 4, save. Pip freeze with the greater than sign, requirements.txt to snapshot your exact dependency. Stage 5, protect. You echo your env to the get ignore file to ensure these environments never gets committed. These 5 stages happen once per project in this order. After the initial setup, your daily workflow is just activate, work, deactivate. The entire environment is reproducible by using the requirement.txt at any time. The sequence is not optional, it is the foundation for everything else this course builds on. Here's a cheat sheet that is your permanent reference for the complete virtual environment workflow. 3 columns over the full picture. Environment commands, so python 3-venv.venv to create. Source.venv bin activate. On Mac, it is the source.venv scripts to activate. On Windows, to activate and deactivate to exit. Package commands. Pip install package to install, pip list to see what's installed, pip freeze with your requirements.txt to take a snapshot, and pip install -r requirements to rebuild from scratch. Some system commands that were used. Echo.venv to get ignore to protect your repo. Nano ~zhushrc or code ~zhushrc to set up aliases, and source zhushrc to apply changes. Screenshot the slide to keep it open as a reference tab. The entire professional Python workflow lives on this one page. Everything you've learned today feeds directly into the module's submission ritual.